Hello guys, welcome back. It's time again for another Leetcode problem. This time we're going to solve Leetcode number 797, all paths from source to target. This one is yet again another medium level question. Okay, this time instead of going through a matrix, we are going to work with a graph. So let's take a look at the problem description here, which says, given a directed acyclic graph, or DAG, of any nodes, so we have any nodes, that's the size of the graph, labeled from 0 to n minus 1. So if you have 4, they will be labeled from 0 to 3, as you can see here. Find all possible paths from node 0 to node n minus 1 and return them in any order. The graph is given as follows. Graph I is a list of all nodes you can visit from node I, which means there is a directed edge from node I to node graph ij. And then they give us the example here. So this is the graphical representation. So the input is this array of arrays, which are all the nodes we can get from that index. So 1, 2, 3, 3, and this is where it ends. So the expected output here are 2 arrays. So that's going to be 0, 1, and 3, and 0, 2, and 3. Let's quick take a look at my whiteboard here, so I can give you guys a more in-depth view of the problem. So let's say we have this input. So this is exactly what we have in here for our input, and this is the output as well. So, but let's pay attention only on the input at this point in time. So I have this graph, 0 goes to 1, 2, 1 goes to 3, 2 goes to 3, and then 3 is the where it ends. I don't know for you guys, but for me it's a little bit hard to visualize this way. But another way to see this is via an adjacent list. If you guys can see here, the index 0 can go to 1 and 2, index 1 goes to 3, index 2 goes to 3, and 3 is where it ends. So this is another way to see the problem. So just based on the adjacent list here, which is exactly the has the same values from here, it's only a better representation for the problem, I would say. We can take a look at that graph. Let me, yeah, I think that's better to just take a look at that our graph. Okay, let's say we have this graph, which is the same as we saw from Leetcode. Now we can say that 0 can go only to 1 because it's a directed acyclic graph, which means the edges they have direction. I cannot go from 1 to 0. I have to go from 0 to 1, and from 1 I can go to 3. Likewise, from 0 I can go to 2, and from 2 I can go to 3. And that's basically why they expect that solution, which is 0, 1, and 3, which is exactly this path here, and also 0, 2, and 3, which is this path here. Okay, we have this path here, 0, 1, 3, and 0, 2, and 3. This is basically what has been asked to us on the Leetcode question. I'm just add this in an array form. So this is how our algorithm is gonna work. And we're going to use backtracking once again to solve this problem. As I said in my previous video, I think I said that, every time we see how many times or how many paths, how many ways on doing something, it usually hints us that backtracking is the most appropriated solution. What we're gonna do is exactly what we did here manually. We're going to start from 0, and then we're going to walk until we reach 3. Quickly here, again, I'm gonna just create an instance variable here that's gonna point to our graph. That's gonna help us not to keep passing things on the methods. Likewise, our n. Remember that n here is it's gonna be size -1. This is where we have to stop. And then we can we also need another instance variable. That's going to be our result. It does not have to be an instance variable. I'm just adding here because it makes our lives simpler, but we could just create as variables inside the method and then keep passing them around. But this way our code is going to be a little bit simpler and more clear, I would say, instead of have those crazy huge parameters. Okay. I'm gonna say, okay, just graph assign n is gonna receive the size of the graph -1. That's exactly what they are asking here. This is where we know we should stop looking for the solution, because we have reached the solution. Result is new array list, and we're gonna need another list because we need to keep track on the path that we are right now. As you can see here, 0, 1, 3, this is one path, and 0, 2, 3, it's another path. So that's why we need to keep track on another variable before adding to the result. It's gonna be, I'm gonna call it path. It's gonna be a new array list, and that's it. As the question says, we have to start from 0. So we're gonna add 0 to our path, and last thing here is to return result. And here is where the magic happens. I'm gonna create a function called backtracking. This is the function that's gonna do all the magic. I'm gonna pass the first node, which is node 0, and that's where we start. And also I'm gonna pass path, because you need to record where are we going and which are the values. Okay, now let's create our main method here, backtracking. It's going to receive I, which is an integer, or we could say node here, or whatever terminology it's best. Let's say node. I think that's more appropriate. And then we also gonna receive a list of integers, which is our path. As for any backtracking or recursive solution, the first thing we have to do is to tell the code where to stop. We should stop when we reach the solution, which is basically when node is equals to n. Remember that's the size of the graph. That's n minus 1. That's it. We have 4, and then we'll reach the solution whenever we have 3 of them. And that is the point where we add that path to the result. Okay. We're simply copying data release, because as we backtrack, we have to remove something from that list and then add something else. Should simply return. And here we have to go through all the elements from here. So for int next receives graph node. Okay, for example, I'm going to receive this one first, because that's 0. That's where it starts. And then I'm going to add next to the path. So that's going to be 1 here, because that's the next one I'm going to receive from this first array. I'm going to call backtracking again, passing next, also passing path. So that's going to go again and reach 2, which I'm going to ask for next, which is 2 here, which is the number 3, and then we'll be at the end of our search. Once it backtracks, I have to remove the last element, path.size minus 1. So I'm just removing the last element, because as we backtrack, we have to follow another path. So it's going to backtrack until it reaches 0 again, and then it's going to 2, as this is the second element from that first array. And once it goes deep to backtracking again, it reaches 3 once again. Okay. Yeah, I think that's it. Looks good. Let's try running the code. Yeah, it passes. And let's try submitting the code. Yeah, it also passes. Yeah, one tip I can give you guys here is to try running the code into your IDE, because you can simply also debug and see all the call stacks if you guys are not too familiar with recursion and backtracking. But that's basically how it works. What we did was we simply explored all paths until getting to the last node here. I hope you guys have enjoyed. Please like the video and also subscribe to the channel, as it helps us a lot. Also, leave some comments in the description below if you guys have any, and I'll see you guys in the next video. Bye bye.